This video is going to go over the C1 and C2 quiz review. So with numbers 1 and 2, it says find the length of the sides of the triangle using the given points and then classify the triangle as equilateral, isosceles, or right. So this is the one we're going to use the distance formula to find the length of the three sides and then compare them from there. So if I do A, B first, I get square root of 13 minus 1 squared plus 5 minus 0 squared, square root of 12 squared plus 5 squared, 144 plus 25, square root of 169. And that's 13. Then I'm going to repeat that for BC. Square root of 13 minus 13 squared plus 0 minus 5 squared. 0, negative 5, square root of 25, which is 5. And then the last one, AC. 13 minus 1, 0 minus 0. And I get square root 12 squared, square root of 144, or goes just to 12 because square of the square root is going to cancel out. That's AC. Okay, so already I can rule out equilateral or isosceles because none of the three side lengths are the same. So then I'm going to check for right. In order for to rewrite, 5 squared plus 13 squared. I'm sorry, 5 squared plus 12 squared would equal 13 squared. And 25 plus 144 is 169, which is what 13 squared is. So this is a right triangle. Okay, now we're going to look at 2. Same process. JK, square root of 4 minus 2 squared, negative 4 minus 6 squared, 2 squared, negative 10 squared, which is 104. Now, if I'm answering this length, I'm going to make sure that this can be simplified. So if this is like 2 and 52, which is 2 and 26, which is 2 and 13. There are 2 2's, so a 2 is going to go to the outside. The 2 and the 13 would get multiplied together and stay underneath. That's JK. Then KL, negative 6 minus 4, negative 2 minus a negative 4 becomes plus 4, negative 10, 2, 100 plus 4, 104. So now we've got two sides the same. We also know that this is 2 square root 26. And now we want to look at the last one, which would be JL. Negative 6 minus 2, negative 2 minus 6, negative 8, negative 8, 64 plus 64, 128. So I know this is not equilateral. I'm going to break this down. 2 and 64 is 8 and 8. So I can bring out that pair of 8s and then keep the 2 underneath. That's JL. So we've got JK was 2 square root 26, KL same, and JL 8 square root 2. So this is isosceles. Okay, for the next section of questions, they all have the same set of instructions. Find the intercepts, test for symmetry, and then sketch the graph. So for 3, I'll start with my y-intercept. I'm going to plug 0 in for x. 0 plus y squared minus 6 equals 0. I get y squared equals 6. And square root both sides, putting that plus and minus in the front. So there are 2 y-intercepts. Negative square root 6. Sorry, 0, negative square root 6, and 0, positive square root 6. Then I do my x-intercepts. So I'm going to make the y 0. X plus 0 squared minus 6 equals 0. X minus 6 equals 0, and x equals 6. And there's my x-intercepts. And then our test for symmetry. So x-axis symmetry, I plug y in, or negative y in for y. And this time it goes back to the original. So it does have x-axis symmetry. Y-axis, I plug negative x in. Does not go back to the original, only the x's change. So it does not have y-axis symmetry. And then origin, I plug both negative x and negative y. The y is going to go back positive, but the x would have change signs. So my origin would also fail. Okay, so now let's put together what we've got to graph. Square root 6 is obviously not a whole number, so we're going to approximate it. It's a little bit bigger than square root 4. So we're going to say it's a little bit bigger than 2, maybe like 2.2 or 2.3, something like that. It's a total estimate, so it doesn't matter. So I go 0 and then down about 2.2, 2.3, and 0 up, 2.2, 2.3. And then my x-intercept is 6. 1, 2, 3, 4, 5, 6 here. And it has x-axis symmetry, which means whatever's happening on the top is happening on the bottom, which is accurate and consistent with what we found. Because it's a y squared, I actually know this is a parabola. It's just turned on its side and looks something like that. All right, for y equals x to the third. So my y-intercept, plug 0 in for y, or 0 in for x. And I get y equals 0, which means that's also my x-intercept. If I plug 0 in for y, and then I cube root both sides, the cube root of 0 is 0. For x-axis symmetry, I'm going to plug a negative y in. It does not go back to normal, so it does not work. I'm going to plug in a negative x. It goes inside the parentheses. That becomes negative x to the third, doesn't go back to the original. And they're not all opposite, so it fails the y-axis symmetry too. And then for origin, negative y and negative x, this is the time in which they both change. So it does have origin symmetry. So the only point I have is 0, 0, which means I need to plug in some points. So if I plug in 1, for example, y would equal 1 cubed, and that's 1. If I plug in 2, y would equal 2 cubed, and that's 8. So now I'm taking it all the way up here somewhere. Now if I plug in negative 1 and negative 2, I should get the opposites. If it's 1, 1, then it's negative 1, negative 1. And if it's 2, 8, then it's negative 2, negative 8. If you remember your parent functions, your cubic function looks something like this. If you don't, then you're simply plugging in those points. All right, 5. X-intercepts, or y-intercepts, let's start again. So we keep consistent. Y equals 0 squared minus 4. Y equals negative 4. X-intercept, 0 equals x squared minus 4. X squared would equal 4, and x would equal plus and minus the square root of 4, which is plus and minus 2. Your test for symmetry, x-axis, I would make the y negative, doesn't change at all, doesn't go back to the original, so that fails. Y-axis, I'm going to plug in the negative x. The squaring makes that go back to positive x squared, so it matches the original, and the origin, negative y stays, but the negative on the x goes away. It either all has to equal the original or all have to change, so it does not have origin symmetry either. So my coordinate points are 0, negative 4, negative 2, positive 2. If we know our parent functions, this is a parabola, shifted down 4 places. So I know that's what it looks like. If you don't, then you plot some extra points. Okay, number 6, start with your y-intercept. Y equals absolute value of 0 plus 2. Y equals 2. your x-intercept, 0 equals absolute value of x plus 2. Absolute value of x would equal -2. And since there is no absolute value that can result in a negative number, this does not have an x-intercept. Now your symmetry, y-axis symmetry, plug in the -x. A negative inside the absolute value, if it's just the variable there, it's going to make it go back positive. So it does have y-axis. The negative on the y is not going to change. So it fails x-axis. And the negative on the x and the negative on the y, one goes back to the original because this would, but the other does not. So it fails that too. So the only information I have is 0, 2 is my y-intercept. But I also know because it has no x-intercepts that this cannot be, we know it's a v, but it can't be a v that points down or it would have x-intercepts. And it's consistent with what we remember from transformations is that it points up. So if I take and plug in -1 and +1, I'd get absolute value of -1 plus 2, which is 1 plus 2 and 3. And if I take in +1, I get 1 plus 2, which is also 3. All right, 7, y-intercept, y squared equals 12 minus 0 squared. Y squared equals 12. Y would equal plus and minus the square root of 12, or plus and minus 2 root 3. Now to give those as an answer, I'm going to keep them as plus and minus 2 root 3. But when I approximate them, it's easier to approximate them from square root 12. Square root 12 is in between square root 9 and square root 16, so this is like a 3.5. All right, x-intercepts, 0 equals 12. Well, 0 squared equals 12 minus x squared. X squared would equal 12. X equals, again, plus and minus square root 12. So now it's -2 root 3, 0, and 2 root 3, 0. For x-axis symmetry, I plug in the -y. That squared is going to make it go away. So it equals the original. Test for y-axis symmetry. Now I plug in -x. That squared is going to make it go away as well. It equals the original. And origin, both of them are going to go back to the original. So it also has origin symmetry. So if I have 0 plus and minus, we said this is about 3.5 and 0, -3.5. And then I have 3.50 and -3.50. And there's symmetry all around. This is consistent with my equation being a circle. If I move the x over here, I get x squared plus y squared equals 12, which is in standard form for a circle. All right, now I got my circle, find the center and the radius of the circle, sketch the graph. This is in standard form, so I take the center and just change the sign on what follows x and what follows y. So this would be -1, 4. And then if r squared equals 14, then the radius is the square root of 14. That's just 2 and 7, so it doesn't break down. It's in between square root 9 and square root 16. This time a little bit closer to square root 16, so this is maybe like a 3.8. So when I go to graph this circle, I'm going to start at -1, 4. And then I go up, right, down, and left 3.8. So 1, 2, 3.8, 1, 2, 3.8, 1, 2, 3.8, and then 1, 2, 3.8. Terrible circle, but you get the point. All right, number 9, find the equation of a circle with center at -2, 4 that passes through 4, 5. So this is my h and my k, this is my x and my y, and I'm plugging into standard form. X minus h squared plus y minus k squared equals r squared. So 4 minus a -2 becomes +2, plus 5 minus 4 squared 6 squared, 1 squared, 36 plus 1, 37 is your r squared. So I plug back in the h, the k, and the r squared. X minus a negative 2 becomes plus 2 squared plus y minus 4 squared equals 37. Number 10, find the equation of a circle with endpoints of the diameter, negative 2, 4, and 4, 6. So first thing I need to find is my center. I'm going to use the midpoint. So negative 2 plus 4 over 2, 4 plus 6 over 2. And I get 1, 5. Then I'm going to use that coordinate point with 1 as my HK and then one of these as my XY. I'm going to pick the ones that are both positive if that is an option. And I get 4 minus 1 squared plus 6 minus 5 squared equals r squared. R squared is 10. So then I plug back in the h, the k, and the r squared. All right, 11 says draw a scatter plot using the given data and make an inference about the data. So first thing I'm going to do is get myself a little grid. The x-axis is the year. The y-axis is average cell phone cost. So my year is 2015. 2016, 2017, 18, we're going all the way to 2022. 19, 20, 21, 22. And then my Y's are my cell phone costs. So it starts at 89, but it ends at like 400. So I'm going to do these by hundreds. 100, 200, 300, 400. So 2015 is 89, 16, 90, just went up a tiny amount. 2017 took a big jump, 331, 360, 366 actually, and then 361, it came down a little bit, and then went up, 372, 382, and 397. So this definitely had a positive correlation as the years increase. The cost or average cost of a cell phone increased. All right, the next two questions say use your graphing utility to graph the equation and then answer the questions. Okay, so the first thing I did was type in this equation. It's important to note that this negative, because it's a leading negative, has to be this button. It cannot be that button. So when it's a leading negative, it has to be that. Now I'm going to hit graph. And we can see from this that it has 1, 0. So I'm going to go second trace, go to 0, which is the second one. I am left of that already. I just hit enter. And then I want to arrow to the right till I get past it and hit enter again and then let it guess. And there's my 0, 1.3379. So I would round that to 1.338. Okay, then it asks you to find the value of y when x is 2.7. So we go back to the same menu, second trace, and I go value, and then 2.7 and hit enter. And my y is negative 29.7 or 076. Okay, so again, first thing I did was plug in the equation, x to the third minus 1.5x squared minus 2.5x. Then I'm gonna hit graph, and you'll see from this graph there are 3 zeros. So second trace, I'm going to find the first one. I'm actually going to go in order. So from left to right. So I'm going to take the little spider. It's all the way down. And there it is. That's left of the first 0. Now I'm going to go right of the first 0 and then hit enter. -1 is the first one. Second trace, do 0 again. This time I'm going left of that second one. Then I want to go right of the second one, and then I want to go to 0. And there's the second one, which is 0. Second trace, 0. I want to go left of the last one, right of the last one, and brings you to 2.5. So -1, 0, and 2.5 are my zeros. Now it wanted to know the value of y when x was -3.2. So second trace, go to value, -3.2, and my y is -40.128. All right, that's the end of your quiz review. Make sure that you study. Make sure that you bring your calculators. Make sure they're charged. If you have any questions, I'll be in the room before school. Remember that you're going to start with the calculator part first, and then you will put your calculators on the floor. You'll move on to the second part. You can always go back to the first if there's time, but you will start with the calculator part. Have a great day, guys.